Well, hello everybody, welcome. I've got a really cool problem right here that's kind of an intersection between some algebra and geometry. We have to find the perimeter of this red triangle right here, and the parabola is y equals x squared minus 6. So here are the details. We have an equilateral triangle. We've got the equation of the parabola, as you see, y equals x squared minus 6. If you want to try this on your own without any clues, right now would be the time to pause the video and give it a shot. I think you're going to have a great time. I absolutely loved this question. I had a really good time doing it. I did it in a couple ways. I'm going to share one of those solutions with you here right now. So here's the math we're going to end up using, right? Of course, it's a triangle. It's equilateral, so we're going to use properties of equilateral triangles, and often when we have an equilateral triangle, we make that into a 30, 60, 90. Both of those things will happen. We're going to have to deal with some radical expressions, and we're also going to have to recognize how the line of symmetry and horizontal pairs of points on parabolas are equal distance from that line of symmetry. That's going to be a key idea. It's related to the equilateral triangle, and we're going to have a quadratic equation to solve, and it's a really cool thing that happens that there is a contextual limitation of this question that's going to allow us to eliminate one of our two answers, which leaves us with just one option, and that gives us our solution. So if you tried the video or you tried the problem, you couldn't get it, and now you're here. With these clues, maybe you have enough, so go ahead and pause it, try it again, and we're going to dive into the solution now. All right, with these kinds of questions, you don't know the solution right away. You have to play around with stuff. I always try to grab something easy. So since the equation is y equals x squared minus 6, I know that the y-intercept is 0, negative 6, and it turns out that that is going to be super important later. So we're going to make sure we got that under our hat. All right, let's talk about the distance from the origin to this horizontal side. We could say that's some distance k. Since that's some distance k, and this side is horizontal, we could actually describe this line right here with another equation. Y equals a number is a horizontal line, so y equals k. It's actually negative k because it's below the x-axis, but it doesn't really matter. K could be a positive or a negative number in this situation, and this is a distance, so it's positive, right? Now, we have a system of equations. Right here, y equals x squared minus 6 and y equals k. So we can use those to figure out what does x equal when y equals k. We're going to set them equal, and we're going to use inverse operations, take the square root of both sides. When x is the square root of k plus 6, y equals k. Well, that's important because that tells us that the horizontal distance from the line of symmetry, which is the y-axis, is k, square root of k plus 6. So that means that that side, half of the base, the horizontal base of the equilateral triangle, is square root of k plus 6. So the other side is also square root of k plus 6 because of the line of symmetry, and that means all three sides are 2 times the square root of k plus 6. All right, let's zoom in on our triangle right here, kind of clean up our picture. We'll come back to the parabola here in a little bit. But that distance k, well, that's a perpendicular bisector, so that creates a 30, 60, 90 right triangle for us. We know these two sides, we know this is k, but we need another way to express this side so that we can figure out what number k actually equals. Well, we could use this right here. So whatever the hypotenuse is, the short side's half of that. And the long side is that short side's distance times the square root of 3. So here's what we've got. We've got 3 times the square root of k plus 6 is this horizontal distance, and that horizontal distance also equals k. So we're going to set those two things equal in an equation, and we're going to solve it. So let's go ahead and clean up these radical expressions over there. We can multiply them, and then let's go ahead and, well, just solve them. We're going to take both sides and square it, right? Square root squared is, well, just the radicand. And then we're going to put everything on one side, setting a quadratic equation equal to 0. This one turns out to be factorable, which is just wonderful. So as you can see, we get k is either equal to 6 or it's equal to negative 3. All right, so let's go ahead and put our whole picture back together right here. Here's what we've got. K is either equal to 6 or negative 3. How do we know which one? Well, let's take a look at the 6. If k equals 6, well, that means that this horizontal side would be all the way down here, and, well, that would leave us without a triangle at all. So k can't be 6, so k must be negative 3. Well, so then all you got to do is plug negative 3 in, right, and you get 2 root 3 is what each side of this equilateral triangle equals. So the perimeter The three sides added up. Boom, we're done. 6 root 3. I really liked that problem. I thought it was so cool and clean. I think it's a fantastic high school level, challenging math problem. I hope maybe you can use it in your class. I'll leave you a link where you can download the PowerPoint I used to make this video. Maybe you can adapt it, use it with your students. If so, I'd really love to hear from you. If you like the video, give me a like, comment, subscribe, all that kind of cool stuff. If you're a math teacher and you had fun with this problem and you'd like to use problems like this or other fun things to engage students in math, I've got a website and a Teachers Pay Teachers store. I'll leave links to all that stuff in the description. Hey, until next time, I hope you have a great day.